Good morning, Vietnam. So, on the picture is a jet engine, okay? So the big fan you see in the front of the engine is the one pulling the plane, pulling it forward. Okay, just like the old planes, it never changed. It never changed. A plane is not a rocket. Okay, a plane is a plane, and it never changed. So back in the days, they had those propellers, and the blades are shaped as air wings. And when they turn in the air, they create this depression in the front. So they are pulled forward, and they pull the plane with them. It never changed. Now they say it themselves. So in the link, a pilot of the company Transavia, he says it himself. He says this propeller, this big fan, pulls the plane. It's 90% of the power is there, is this stuff pulling the plane forward. So the principle never changed. And now they say it themselves. You know, truth always has to be said at certain moment. Yes. So this propeller in the jet engine pulls the plane with the power from 15 to 30 tons, depending on the airplane. It's something like that. So you have to imagine this stuff pulling at 15 tons to 30 tons, but also spinning. So imagine the bearing, work and charge on them, forces on them, bearings of the spinning and pulling. So there is big force and spinning at very high speed. So you have to deal with this mechanical work. Mechanical work generate heat and need lubrication. Needs lubrication. Okay, just the mechanical work. Okay, so on your car engine, what kind of fluids you have? What kind of fluids? You have the fuel, okay, that you burn and you extract mechanical power from it. And you have the oil to lubricate the engine itself. Okay, there is forces between the cam shaft and everything. Okay, the rods, the crankshaft. It generates heat. It needs lubrication, and this friction generates heat that you have to deal with. Actually, this oil in the engine is taking the heat and exchanging it also with the cooling system, with the water system. So there is places when this water comes and exchange the heat with the oil itself to lower the temperature of this oil. Okay, a heat exchanger. So you have, like I said, you have the fuel, you have the oil, and you have the water system for cooling with the radiator. So those systems, we don't see them on the jet engine. Okay, we don't see them. Where is the lubricating part of those bearings? Okay, where is the oil carter, the cooling of this oil carter? Where are the radiators? Where is the cooling fluid of the radiators? On some cars, even the gearbox, imagine the gearbox, which is just cogs, because it can be a performance car. The gearbox in itself can generate heat too much. So it needs, they even need to think about managing the cooling of a gearbox. Okay, just because the cogs and this power transmitted to the wheels and friction between the cogs, you need lubrication and cooling of this. So we don't see this in the jet engine. Okay, so we will assume that this fluid they put is managing lubrication because it's needed, and the cooling part also. Okay, so it is injected there, lubricating those bearings and cooling them. Because we don't have a cooling system, it's not there, and it's 15 tons, guys, continuously of pulling power. You know, the plane is always flying, always pushing against the air, so it's a continuous work. Okay, and when the planes are on the land, we don't see them checking the oil level, okay, or changing the oil from time to time. Okay, because the oil itself is what they put, is this kerosene stuff. Okay, that get thrown, continuously thrown, not like a car engine where the oil is there, staying there, and check the level, change it every 5,000 miles or something like that. So we don't have this. So the liquid they put is the lubricating and is the cooling system. You cannot throw it in nature like this. Once it takes the heat of the bearings and lubricate them, they burn it in the back end of the jet engine. Okay, in a hot zone. So the amount of liquid they put must be a fraction of what they say. Like they divide by, I don't know, 10, 20 more. So it's all bullshit, this quantity they put. Don't ask me how this trick keep going. This is another level of the matrix. But I imagine on the plane itself, just those stuff that meters how much you have of lubricant left on the plane, cooling lubricant, kerosene, how much is left. The meter themselves have a zero more or something. you know, it's just a little trick. So there is not these quantities. There must be a tank somewhere. Small. All this, all this mythology in the wings and all this. I don't know how it stands, guys. It's very crazy. So this is what I want to say about this jet engines, marvels. So I said the principle never changed, but the way it works very much changed. So back in the days, we will imagine that the power was from a piston engine, just like your car. You burn fuel to spin an engine, and this engine is connected with the rod to the propellers of the plane that will pull the plane forwards. And then appeared this vortex collapsing technology. And now we have another way to have, power. It was the era of Schauberger. Okay. So this vortex collapses in the core of the engine. There is those two, spinning parts. It's like a stacking of blades going more and more narrow, like a collapsing vortex. And then another counter rotating part which goes from the smaller to the bigger stacking of blades in the core of the engine. Okay, and this is what generate the vortex. It is started, you hear it being started in the engines, so they start spinning this stuffs slowly, okay, with compressed air till it is sustained. The vortex is collapsing, and there is this resonance between those two parts, opposite parts, and you have your engine, your vortex collapsing engine. Okay, in a very simply explained. This engine turbine, it is what is used in helicopter. Okay, helicopter. It has a turbine and a rod which goes to the blades over the helicopter. And this is how a helicopter fly. He has a turbine vortex collapsing engine, Schauberger technology. this is what we have in the electricity plant. You know, when they generate electricity for the cities, they use this vortex collapsing phenomena. This is why there was never a problem of electricity, of energy, never, guys. There will not be like a problem of generating electricity, too much electric cars. Or believe me, you go in any shithole of this planet, you will find electricity. There is a few companies, I don't know how many, General Electrics, maybe some others, I don't know, they make those turbines. They start to spin, the collapses of the vortex starts, and then it's over unity free energy. This is where you have electricity, no problem. There was never a problem of this. So I said, you extract mechanical power from it, from a helicopter, for example. By the way, you don't have access to this technology, okay? As normal level of this human farm, you have piston engine. When you buy an electricity generator for your house, in case you need electricity or there is a cutting of electricity, it will be a piston engine. Even a big company, a building company, goes into some places, there is no electricity, they need electricity for their equipment, their generator will be a piston engine. You will not hear a turbine, okay, generating electricity. Though it is a turbine generating the electricity of the city, or generating the mechanical power of a helicopter. So it's very elitistic technology. It's not for everybody. So I said, you would imagine, back to the jet engine, you will imagine this big fan is mechanically connected to those turbines inside the engine, so it gets moved. Okay, and then it pulls the plane. It might have been this kind of design long time ago, and in some very specific cases now, where the propeller, the big fan, is moved by mechanically by the engine itself, by the collapsing, by those like I said, packed blades that goes more and more narrow. There is some cases where there is like a helicopter, you directly with the shaft extract this mechanical power. Maybe in a plane, you know, this plane of the US military that can take off like a helicopter, you know, it has big blades, it can rotate, the engine rotates, and then the plane goes up, and then it can go to a plane mode. It has big fans like this. So those are mechanically connected to a Vortex Schauberger engine, mechanically. But something happened with this a commercial jet engine, which is a beauty of engineering. This big fan you see in the picture is just a free wheel. Okay, it just spins freely. So how does it work? So when the vortex generators start collapsing the air starts to collapse in this big engine, you know? And this free wheel fan, you know, start to react to this air going to it. Okay, because of the shape of its blades, it start also to turn, counter-rotating the vortex. And those blades are shaped like wings. So the air going through this big fan, this propeller of the jet engine you see on the picture, will slowly start to make it spin. This is what you see when they start the engine. You hear the sound of the compressor and the speed of the internal engine very, very fast, and the propeller, this external propeller, is barely starting to move. Barely. Okay, so it's just a free wheel that will react to this collapsing air and gain more and more speed. But the design of this propeller, this big fan, is like wings of plane. So counter-rotating the vortex makes those blades sucked forward. So the whole The whole propeller is wanting to go forward. Therefore, the pulling power of this propeller. It's a beautiful. So I think they get rid of this mechanical connection. Now they only use the air collapsing. Okay, for extracting this power to move the plane, they just rely on this big fan starting to spin, and the design of its wings make it being pulled forward. We can think of an example, just to give you an example how this is possible. Think about the sailing boats. Sailing boats can go up the wind. The wind is coming from forward, but I want to travel against the wind. I can. With the sailing boat, I can. So the boat goes zigzagging left and right up the wind. So the wind are pulling on those sails. The wind is pulling on those, pushing on those sails, but sideways. And the whole design and the way to navigate make this boat able to go up the wind, zigzagging left, right, but it's going up the wind. So it's the same stuff. Very simplistic, but for you to understand that this is possible. To close the video, the pilot of Transavia you see on the picture performs a check on the plane. There is a check the pilot has to do before taking off. They go around the plane and check if there is nothing, with their eyes, check the tires, the wings, if there is something stuck somewhere. And when he gets to the engines, and explaining that the engine is pulled by the fan, it's not like people believed in the time, like it is the gases going out of the engine that moves it like a rocket. He said this is bullshit. He said it's 90% this fan pulling the plane. He said it himself in the video. So the interesting part, when they performed this checking of the plane, they used to, with their hand, give a spin to this big fan. They used to turn it like this. Okay, it was normal, just to turn it, see if everything okay, if mechanically it sounds okay, nothing wrong. Okay, so they used with their hand, the pilots, to give it a spin. And now he said that they are asked not to do it. Okay, they are asked, no, it's not necessary anymore. So it made me laugh. Why? So I imagine now, because of the precision of the machining, the precision of the machining of the building those stuff, the bearings, the materials, the quality of the materials, the alloys. There is very much low friction, guys. So when he gives it a spin like this, it's obvious that this stuff is connected to nothing, okay? I mean, it's not connected to the rest of the mechanic, but connected to a very strong bearing and connected to the structure of the plane to pull the plane. So they asked them, just don't do it. It becomes too obvious that, they don't want to show that there is nothing, okay? So yeah, this is the point. So don't touch it, don't turn it, okay? It's okay. Yeah, and you can see in a video clip, also music clip, where an old music clip where turning this video clip of music, the singer just spins those fans. I can also put you the link here. Yeah, a little bit of personal experience on the planes. So in my last traveling, because I understand this and my engineering parts and liking the beauty of these stuffs. There is speed, acceleration, there is a lot of emotionality. You are flying in the sky, okay, with a very lightweight object, very safe, beauties, marvels. So one of my last planes, I felt really the emotion, the acceleration. He was holding the brakes. We were on the landing on the taking off, path. waiting to take off. So he's building this speed. So you hear the noise getting louder as the speed of the air collapses more, and he is holding the plane with the brakes of the wheel to build this pulling power. So he built it to a certain level. So you hear, you know, the noise getting more strong, and I felt those, you know, those propellers, you know, pulling the plane, but the plane is held back by the brakes of the wheels. Then he let go of the brakes, and you have this crazy acceleration, you know, crazy. It's a, you know, it's a lot of sensations, you know, and the speed building that quick, you know, this constant acceleration, because those propellers are continuously pulling the plane, you know, constant force, and the speed builds, and then we take off, and suddenly there is the clouds, you know. We are climbing, and then you are clouds. You see the clouds now, you know, few seconds, and you are over the. I went emotional, guy. I really went emotional. So yeah, now I feel the stuff, how it works and everything. I feel the lightness of it, the beauty of it, the safety of it. Yeah, so that was one, and then there was another flight after it. And very particular, this one, very special, because I was on Airbus A320 Neo. So a relatively new plane, put in service in 2014, and there was something different. So I was waiting for this, you know, sensation of the taking off, the drama of it, the beauty, the noise of it. And everything was less dramatic. Like the plane didn't need that much speed to take off, less noise, less speed. Like I said, the acceleration even less brutal, and the speed of taking off obviously less. Okay, so I said, oh, it's very less crazy than the other plane. Okay, and I started checking what is this plane. Okay, well, what is this plane I'm on in? And I discovered it's the Airbus A320 Neo. Okay, and I started to look around what's new in this plane. Already, guys, the seats were very thinner. Okay, the seats on the plane used to be something, okay, like thick and stuff, a lot of aluminum, a lot of material. So they were really thick, not only reducing the space needed in the plane, so they can maybe put more of people, but also the weight of them. Imagine if they save I don't know how many kilos on each seat. Imagine you save 5-10 kilos on each seat, and there is 150-200 seats, so it's a lot of weight already cut by the seats themselves. The new materials, the new composite, it is a relatively new plane, guys. 2014. Very new for the planes, you know, they have a longer time of service. So obviously it was lighter, needing less speed to take off. The material very light. They really cut the weight where they could. All the lightings are LEDs. Even the out lighting of the plane, you know, signaling himself. The pilot himself in this Transavia video, he says himself that everything is now LEDs. There is no not the old bulbs, so everything is lightened. So imagine how many weight they shade out of this plane. He said that the braking are carbon now, the discs carbon something, so everything more efficient. So really less speed, guys, less needing of speed to take off, less needing of less noise, and the landing also, when we landed also, guys, are very different, because when they land, they used to do a lot of, you know, effort to slow this plane. So you see all this aerodynamic work on the plane and everything, you know, some flaps going up, you know, a lot of stuff happening to try to slow this plane. And this Airbus, when it's landed, it's like relied on the braking of the wheel only, and the speed of the landing. The speed we land, it's obviously lower. So everything is lower needed because of the weight, efficiency, And in the video he says that it is very much more efficient in fuel. You imagine you need less lubricant and coolant stuff on this stuff, 20% less or something he said. So that was my personal experience. Guys, I think we did enough on this subject. Unless something crazy happens, I think I close this subject. That will be the video that sums it more or less. Not many photos, I'm sorry, but I'm not really a YouTuber with the production effort and everything. But the people who needs the information, I think it's an okay video. See you in the next one.